Do you know the grains of beans? Yes?
No.
The bean seeds. We don't know the seeds. Yes? You know the bean seeds, isn't it?
Yes.
Now,
Yeah.
just imagine you have gone to the shop, you are asking for bean seeds of 1,000, and they start counting for you bean seeds one at a time. You get it? And then also
Yes.
estimate a time when they tell you there are many customers at the shop and each wants beans of 10,000, 10,000. How many times will you count the beans? Yes? There will be uncountable ways, isn't it? So if
Yes.
they consider this thing is considered like this. If each bean seed, each bean seed is maybe 0.5 grams, they estimated this to be counted as, if each bean seed is 0.5 grams, it is better to count this in kilos. In kilos, not counting. So instead of counting, you just go and say, I want 5 kilograms of beans. Then they weigh for you and they give you the kilos. But if they count how many beans are in a kilo, then they start counting for 5 kilograms. It is tricky. It becomes hard, isn't it? Also, books the
Yes.
same way. Books. They sell books in dozens. So that if you say, I want a dozen of books, they just carry a dozen and put for you. Instead, if you say, I want 45 books, and then they start carrying, counting one book. Imagine you have 20 customers. How long will the person take to carry the books? It will be too much, isn't it? That is the same
Yes.
way. That is the same word to mean a mole. Now, instead of saying a mole, you know, a mole is something very big. In somebody WhatsApping when you're in the lesson. So here, you look at this. In 1 mole of a given substance, 1 mole, only 1 mole, what they say a mole, 1 mole, we have 6.02 times 10 to power 23 particles inside. Only one mole of a substance. It has this, just like a dozen of books. 1 dozen of a book has how many books? Yes? A dozen,
12.
12 of them.
12.
So instead of counting this, they say, I want a dozen of books, they just carry for you 12 of what? Books, you go. So even here, do you see how big this number is? Do you see how big that number is?
Yes.
So this is 1 mole of a substance. It has this number of particles. So if you want to know this number of particles, even a calculator will work and it becomes hard. Do you know how to press this on a calculator? Now, there is 6.02. Please, let's minimize noise on the ground. Please learn to manage your microphone. If you're in a noisy place, try and look for somewhere. Look for somewhere to be. At least in a quiet place. We are mature and I don't expect noise on the ground. Cynthia.
That's not me.
Oh, peace. Peace. So here, if you're writing this number on the calculator, it's going to be 6.02. Then there is somewhere written exponent, that letter E on the calculator. You press E instead of this. E is the same as x power 10. This is E. Then you put 23. 6.02 exponent 23. and you see what a calculator will give you. You have your calculators? Alexandria,
Yes.
you have the calculator around?
Yes.
Yes. So you press for me that figure and check if it is equal to this one. Press 6.02, then you look for that letter E somewhere. It means exponent. It's the same as x power 10, x times 10. Then this power here is the one you put at 23.
It's the same answer.
It is the same answer. So I don't expect you to go and look for other ways of pressing this whatever, pressing calculator to look for this number here. So make sure you know how to use your calculator very well, because these numbers are very big. Once you misfire them, they will mislead you. Okay? So here they are saying mole concept deals with determining or counting the number of particles. Since the number of particles is large in quantities, you see this number of particles, it is very large. It becomes very difficult to deal with large numbers. Therefore, these particles are placed in groups called what? Moles. So 1 mole of a substance has this number of particles. 1 mole of a substance has this number of particles. So these particles of a substance grouped into moles can be molecules. You know a molecule? An example of a molecule is water. Water molecule. So 1 mole of water molecule, so we are not seeing, 1 mole of water molecule is equivalent to 6.02 times 10 to the power 23 particles. As long as it is 1 mole, it is the same as that. A mole of an atom. An atom is 1, like 1 mole of copper. 1 mole of copper. This is an atom. Is equivalent to 6.02 times 10 to the power 23 particles. Those are the number of particles in 1 mole of this. But if they say in 2 moles of copper, this is not, you multiply the answer by what? By 2. If they say find the number of particles in 2 moles of copper, you just say 1 mole of copper contains 6.02 times 10 to the power 23 particles. What about 2 moles? This is 1. What about 2 moles? 2 moles of copper contains 2 times 6.02 times 10 to the power 23 particles. What is the answer there? What is the answer there?
1.2.
Someone with a calculator, get for us the answer. What is the answer?
1.204.
1.204 exponent
Times
10
1.
power 25.
To power 25. Now
24.
the power
24.
is
So it's
24. Okay.
Yeah.
24 particles.
Huh?
These are the number of particles present in 2 moles of copper. So this is what we say atoms.
Yes.
Atoms here.
Chicken.
Then when we say ions, this is the ionic nature of substances. Like, what is the number of moles? Number of moles in 2 hydrogen ions of, these are now ions. This is atom. This is a molecule. So all of them, this one is a molecule, this one here, molecule. This is an atom, one element. This is the iron. When we were there with senior twos, most of you were not there in the morning. I don't know what was there. We did some calculations on solubility. So next time endeavor to attend both senior 2 and 3 work. Because senior 2s can't attend this because they still have actually everything of theirs is still low. Chemistry is still low, but for you, you have to get these things as fast as you can because you are our next candidates. The others have gone, we are now waiting for you. So here we have this number of moles in 2, actually not moles, but the number of particles in 2 hydrogen ions. You say 1 mole of hydrogen ion contains 6.02 times 10 power 23 particles. What about 2 moles of the hydrogen ion? This is the ion nature of substance. So it becomes 2 times 6.02 times 10 power 23 particles. So the answer still comes back to 1.204 times 10 power 24. These are particles. Now, it is the same thing with electrons. It is the same thing with the radicals. You know radicals? Radicals like sulfates, nitrates. So anything they bring, as long as 1 mole, it is equivalent to this number of particles. But if the moles increase, even the number of particles increase. So here, protons or any other specified particles. For example, 1 mole of magnesium atom, this is magnesium atom. It has this number of particles. 1 mole of magnesium ion has these particles. These are now ions. 1 mole of sulfuric acid, these are aqueous state of something and it's a molecule. It has this number of particles. So as long as they say 1 mole, you just know it's equivalent to this number of what? Particles. So a mole is the amount of a substance which contains 6.02 times 10 power 23 particles. This number, we see 6.023, was discovered by this man here, Avogadro, and it is called Avogadro's number. So 6.02 is called Avogadro's number. It is a constant. It was determined long ago for us to just follow. So it is denoted by letter L, but instead of using L, if you know the number, it's better just use the L number. So that is 1. 2, if they talk of the molar mass is the mass of 1 mole of a substance. The mass is the quantity something contains. So what the mass of 1 mole of a substance, like here in this table, you look at this. Hydrogen, its relative atomic mass is this. The molar mass is what? 1 gram. So it is equivalent to the relative atomic mass expressed in grams. It is equivalent to relative atomic mass. Here are elements with their atomic masses. But if they want the molar mass, it is in grams. You just put it in grams. That's the molar mass. But if they ask for relative atomic mass, there is no gram. You just write it like that. So this is for 1. This is for 1 element. The relative atomic mass of elements has already been established. You don't need to look for the relative atomic mass of hydrogen. It was established long time ago. So just know that hydrogen, its relative atomic mass is 1. It is whatever is 1, the molar mass. Carbon is 12. This is 12 grams of carbon. Oxygen is 16. This is for only O. But if they want the oxygen molecule, it becomes O2. Oxygen can never be written as O. This is a symbol. If they find you in chemistry writing O as oxygen, You still belong to senior 1. You need to go and take part in these equations writing. So oxygen is a gas and it is O2. So if you want to get the relative atomic mass or the molar mass of oxygen, molar mass of oxygen, it becomes 16 times what? 2. This is 32 grams of oxygen. 32 grams of oxygen. That is what we have there. So take note of things that occur as molecules and then those that occur as the way they are, just one. An example is chlorine. You cannot write chlorine as Cl2, as Cl alone. This is a symbol of chlorine. But chlorine gas is written as Cl2. So this is chlorine. So that is what we have. So if they say one chlorine atom is this, it is relative atomic mass is 35.5. Chlorine is the same as 35.5 plus 35.5, which is equivalent to what? 70. Yes? Is it 70 or 71? Is it 70 or 71?
71.
71. Thank you. So chlorine is 71 grams. So you don't need to, actually what you need to do is to look for ways of getting like the relative atomic mass of all elements in the periodic table, 20 of them, and their relative atomic masses. The rest will be provided to you in case they need them. In chemistry always they put them there because they know cramming these things is hard. But if you know those ones of the 20 elements, there is no need of you cramming. An example is sodium. Sodium. Hydrogen in the periodic table is under group 1. It is 1. Helium is, you look at this table, where is helium? Where's the relative atomic mass of helium? Yes? Who knows? Yes? Relative atomic mass of helium? Yes? Super quiet.
4.
Yes? It is 4. Yes. So those are some of the things you need to know. So most of them are here. Now, if you look at this, the relative formula mass or the molecular mass of a substance, this is the same as the relative. So you have like 4 things. The relative, this is the molecular mass. You have the relative atomic mass. You have the relative formula mass. You have the relative molecular mass. So all these things, there is nothing common with them. They mean the same thing. They are the same. Only that this one is for one atom. This one is for the formula. If they are grouped like ammonium sulfate. Ammonium 2 sulfate. This is for the formula. If they ask for the relative formula mass of this substance, you must get it is relative formula mass. Relative molecular mass, this is for molecules like water. Water H2O, H2O. This is for the molecule, but they all mean the same thing. So if they ask for the formula mass, relative molecular mass of any given substance, you must be in position to calculate. So let's take an example, ammonium sulfate, which is this. So here you come and say this 2 is for both N and H. This is ammonium sulfate. Ammonium sulfate. We learned how to come up with equations with senior 2s in the early days. Ammonium is a radical. It is NH4. It has valence 1. And the sulfate is also a radical of SO4. All of these have a valence of -2 because this is a negative ion, this is a positive ion. So when you are forming this compound, they exchange powers. The 2 just comes outside the bracket, then 1 goes inside. So it remains as ammonium, all these 2, then SO4, which is 1. So it just remains like that. So that's ammonium sulfate. So if they need the relative formula mass of this, we shall say 2 outside, open brackets. What is the relative atomic mass of nitrogen? You come and check in the table. Nitrogen is here, it is 14. You put 14 plus hydrogens, there how many? There are 4. So you put 4 outside here, and then hydrogen, the relative atomic mass is 1.
1.
Yes, plus sulfur. What is the relative atomic mass of sulfur?
30.
32. Okay. Plus, now there are 4
Yes.
oxygens here, which means it is 4 times 16. Relative atomic
16.
mass of oxygen is what? So if you add up these things, it comes to, this is 18. Okay. 4 times 1 is 4 plus 14 is 18 plus 32 plus 4 times 16 is what? 4 times 16?
64.
Yes?
64.
64.
64.
So somebody add up for me all these things and get for me the relative atomic mass of, the relative formula mass of ammonium sulfate. Is equal to what?
132.
132.
132.
2.
That is the relative formula mass of that substance, 132. Now, we know of water is here, it is 18. The one of sodium sulfate is here, copper nitrate. Then now, I want to see people do this one. A part, that one I've highlighted. Iron sulfate, 7 water. Iron sulfate, 7 water. I'm giving people 3 minutes. 3 minutes. And we continue. Iron sulfate, 7 water. This is iron 2 sulfate. They have given you almost everything. Iron is here, sulfur is here, oxygen is here, hydrogen is here. So get for us the relative formula mass of iron sulfate, 7 water. So when you reach here, this water, pay attention to this. This water you add, instead of multiplying, you add plus 7 water. 7 times the whole of this water. 7 is for water alone. So make sure 7 multiplies the relative atomic mass of water. We have a few seconds to go. Mhm. So what is the answer? Yes? What is the answer? Yes?
278.
100?
270.
I'm not hearing.
278.
2?
278.
270.
278.
278.
278.
278.
Yes.
Yes.
Okay. Let's check. Let's check.
Yeah.
So here we have iron. Iron is 50 what? 56, isn't it? 56 plus 32 plus 4 times 32 plus 7 into water is 1 times 2 plus 16, isn't it? Do you have something close to that? You have something
4 times
close?
16, not 30. Yes.
4 times 16.
Yes.
Sorry. 4 times 16. Yeah.
Yeah.
So this one is what?
88.
88. Plus this is 64, isn't it?
64.
Plus this is 7 times 18. You get what? 7
Oh.
times, yes?
126.
Yes?
You get
7 times 18,
126.
126. So add for me all this. Does it come to 278?
yes.
It is 278. Okay.
Yes.
Thank you very much. So now we can determine the relative formula mass of a given compound. Yes?
Yes.
Now, next, you will not be given this formula. You will not be given this formula. They will just tell you what is the relative atomic mass or relative formula mass or relative molecular mass of any given substance. An example is the calcium phosphate. Calcium phosphate. You must be in position to first write the compound called calcium phosphate. Compound called calcium phosphate. Calcium phosphate. Then later you look for its relative molecular mass or relative formula mass. This is not molecular but relative formula mass. So if you cannot come up with this calcium phosphate, then it's going to be tricky. So we have 4 minutes and 18. Can we discuss something on calcium phosphate, the relative atomic mass? Let's determine it. I'm waiting for the answer for the relative formula mass of calcium phosphate. Calcium is there. Calcium is 40. C is 40. Ca is 40. P is, let's go back to the table. Phosphorus is 31. O is 16. Okay. These are the main substance is there. You ask for any other, the one that you don't know. Calcium phosphate. Mhm. Okay, we are coming back after 1 minute. We are coming back after 2 minutes. We continue with our lesson. Coming back after 1 minute.